Hello, I am A.T. Talware, Assistant Professor, Mechanical Engineering Department, Sanjeevani College of Engineering, Kopargaon. This is my second lecture on Unit number 6, Economics of Power Generation. The title of this lecture is Production Cost of Electrical Energy. That is how to find the cost of electrical energy. In this lecture, I will cover the units of electrical energy and its explanation, total cost of electricity production, fixed cost, semi-fixed cost, and running cost. So let us will start. What is the unit of electrical energy? You might be knowing that electrical energy is measured in kWh, read as the kilowatt hour. One unit of electrical energy means 1 kWh, like 2 units means 2 kWh, and so on. For a middle class family of 4 to 5 person may consume the electric energy in the range of 100 to 200 units, means 100 to 200 kilowatt hour. So it depends upon the number of electrical appliances, ratings of electrical appliances, and hours of use. Now I will explain the what is the how will measure the 1 unit of electrical energy. 1 kWh is the amount of electrical energy consumed by 1 kilowatt electrical appliance in 1 hour, or it could be 2 kilowatt electrical appliances in zero point 0.5 hours. So therefore the electrical energy that that is kilowatt hour in kilowatt hour, that is equal to ratings of electrical appliances into hours used. For example, 100 kilowatt electrical appliances used for 2 hours. So how many units have been consumed? So that how to calculate 100 kilowatt into 2 hours. So 200 kWh means 200 units will be consumed. By this is the preliminary required knowledge required for the understanding the economics of power generation. So that's why I have covered initially. Now we'll see what is the economics of power generation. It is the art of determining the per unit, that is for 1 kWh cost of production of electrical energy is known as economics of power generation. The total cost of electricity production includes the fixed cost, semi-fixed cost, and the running cost. Sometimes it is also divided into only two parts, that is fixed cost and the running cost. So in order to find out the cost of production of electrical energy, we need to find the two things. First, how much units have been generated, and second, how much rupees are required for a given number of units. So cost of production of electrical energy, then we can find out, is equal to total cost divided by unit generated, that will give us the in rupees per kWh. For example, 1,000 units means 1000 kWh have been generated in 100 rupees. So 100 rupees is the total cost. So how much rupees are required for 1 kWh? So 100 divided by 1000 gives us zero point 0.1 rupees, that is 10 paise per units. So this is the production cost, how we will calculate the production cost of electric energy. Now we will see one by one what do you mean by the fixed cost. So fixed cost, as per the definition, it is the cost which is independent of maximum demand and units generated. So how many units have been generated, and how much is the maximum demand on the power plant, irrespective of these two parameters, the fixed cost will remain same. The fixed cost is due to the annual cost of central organization, the interest on capital cost of the land, and the salaries of the high officials. So central organization, it means that to run any organization, uh, so a central organization is there, means which includes the high officials like directors, or it could be the managers, and their salaries of high official is considered as a fixed cost, and interest on capital cost of the land. In order to start a power plant, a huge amount is required. So one cannot have a huge amount, so that amount is to be taken from the bank, and the loan on that amount is called as the interest on that loan is considered as a fixed cost. The annual expenditure on the central organization and salaries of high officials, for example, director, presidents, managers, so these are the high officials, is fixed since it has to be met whether the power plant has high or low maximum demand, or it generates less or more units. Irrespective of this maximum demand and the number of units generated, this fixed cost is not going to be changed. Further, the capital investment on the land is fixed, and hence the amount of interest is also fixed. Now, what is the semi-fixed cost? It is the cost which depends upon maximum demand but is independent of units generated. More the maximum demand, more will be the semi-fixed cost, and it is independent of the units generated. The semi-fixed cost is directly proportional to the maximum demand on power station and is an account of annual interest and depreciation on capital investment of building and equipment. So here the new term is introduced, that is a depreciation, so that I am going to cover in lecture number 3, but here I will give you the brief introduction of depreciation, that if we want to replace the old equipment in the power plant, we need to keep some amount aside, so that at the end of the useful life of that equipment we have to replace the old equipment by purchasing the new equipment. So by keeping some amount, that amount is called as a depreciation charges. Okay, so that I will going to cover in the next lecture. So here we have to consider interest and depreciation charges on capital investment of the building and equipment. Then taxes, salaries of management and the clerical staff is also called as a semi-fixed cost. Now the maximum demand on the power station determines its size and cost of installation. Obviously, the greater the maximum demand on a power station, the greater is its size and cost of installation. Further, the taxes and clerical staff depends upon the size of the plant and hence upon maximum demand. Now we will see the running cost. What is the running cost? As you know that running cost, it depends upon the how much is the depends upon the how many units have been generated. The running cost is on account of annual cost of fuel, lubricating cost, lubricating oil cost, maintenance, repairs, and the salaries of operating staff. Here I'll give you the one simple example. If you purchase the motorcycle, the initial cost of the motorcycle will consider as a capital cost, and the running cost of the motorcycle will be the how much fuel is required per month, or how much, it depends upon the usage of that motorcycle, for how long we have used that, for how many kilometers we have run the motorcycle. So running cost depends upon the amount of uses. So Here also in the power plant, the running cost is an account of these four parameters. Now, since these charges depends upon the electrical output, the running cost is directly proportional to the number of units generated by the station. More the units generated, more will be the running cost. In other words, if the power station generates more units, it will have higher running cost and vice versa. So in order to understand and how to apply this theory, we will solve some two problems. The first problem, so let us will consider this first problem. Estimate the generating cost per kilowatt hour delivered from a generating station from the following data: plant capacity 50 megawatt, annual load factor 40%, capital cost 1.2 crores, annual cost of wages, taxation, etc. rupees 4 lakhs, cost of fuel, lubrication, maintenance, etc. 1 paise per kilowatt hour generated, interest 5% per annum, depreciation 6% per annum of initial value. So after reading the statement, so we have to solve this problem. So how will solve the problem? So we require the two things. The first thing is how many units have been generated, and second thing, how much total cost is required. Okay, so these two things are required. So let us will solve this. So the maximum demand on the station may be assumed equal to plant capacity. Since it is not given the maximum demand, so we need to consider the maximum demand is equal to the plant capacity. Here it is 50 megawatt. Now in order to calculate the annual fixed charges, so how much is the interest and depreciation charges? 5% plus 6%, that is 11%. So 11% of what? 11% of capital cost. Capital cost is how much? 1.2 crores. That is equal to rupees 120 into 10 to the power 5 into this 5 plus 6 means interest plus depreciation charges, that is 11%, is this is equal to 13.2 into 10 to the power 5 rupees. Wages and taxation, that is given rupees 4 into 10 to the power 5. Total cost, total annual fixed charges is equal to addition of this will give us rupees 17.2 into 10 to the power 5. Now annual running charges. Running charges, in order to calculate this running charges, so we have to calculate first how many units have been generated. So how to calculate the unit generated? There is a formula: maximum demand load factor into hours in years. So 50 megawatt is given the maximum demand, so we have converted into kilowatt. 50 into 10 to the power 3 into load factor is 0.4, and the hours in a year is 8760 units. So 1752 into 10 to the power 5 kilowatt hour. So these many units have been generated. So cost of fuel lubrication is given, that is 1 paise per units. So multiplied by 0.01 to the number of units will give us rupees 17.52 into 10 to the power 5. So total annual charges is equal to fixed charges plus running charges. So that gives us 34.72 into 10 to the power 5. So cost per kWh is equal to rupees 34.72, that into 10 to the power 5 is the total cost, and this means these rupees are required for how many units? 1752 into 10 to the power 5 units. So by dividing this we'll get the 0.02 rupees, that is 2 paise per kWh, means for 1 unit 2 paises are required. Okay, so we'll go for the second problem, example number 2. A generating station has a maximum demand of 50,000 kilowatt. Calculate the cost per unit generated from the following data. Capital cost is rupees 95 into 10 to the power 6. Annual load factor 40%. Annual cost of fuel and oil is equal to 9 into 10 to the power 6. Taxes, wages and salaries is rupees 7.5 into 10 to the power 6. Interest and depreciation is 12%. So again the same steps we have to follow. We have to calculate the two things to calculate the production cost. First, that how many units have been generated, and second, how much total cost is required for given number of unit generation. So units generated we have to calculate first. So maximum demand into load factor into hours in a years. So that gives this 17.52 into 10 to the power 7 units. Annual fixed charges 12% of the capital cost. So capital cost is how much? That is 95 into 10 to the power 6. So 12% of this will give us 11.4 into 10 to the power 6. Annual running charges. Here running charges is the annual fuel cost plus taxes and wages we have considered here. So sometimes these taxes and wages may be considered the running charges, or it could be considered as a fixed charges. So even if we consider in fixed charges, the cost of generation will not going to be changed. So this point you have to understand. Okay. So total annual charges is equal to the fixed charges as we have calculated in previous slide, that is 11.4 into 10 to the power 6 plus running charges, that is 16.5 into 10 to the power 6, will give us rupees 27.9 into 10 to the power 6. Therefore cost of per unit will be equal to total cost divided by number of units generated. So this will give us 0.16 rupees per kWh, means 16 paise are required for generation of 1 unit of electrical energy. Okay, thank you.